All right, we're going to talk about a really cool application of quadratic equations, quadratic functions, that is dealing with the height of projectiles. A projectile is anything that gets thrown, has kind of an initial velocity, and it's going up in the air somehow, and then after that initial velocity, after all forces get let go, the only force acting on it is gravity to pull it back down. So it goes in this parabola shape. Many of you have taken physics, and you've no doubt studied that a little bit already. It's a pretty common application of quadratic functions. So I'm going to talk to you about that and some of the basic forms there. So this is lesson 8.6. Lesson 8.6 really digs into kind of where these formulas come from. Good stuff. I would encourage you to look at that, but I'm not going to require you to look in depth at this lesson. I'm going to kind of give you what you need to know here. All right. So what we're going to do is we're going to use number 21 on page 530 as a problem to kind of work with. I'm going to add a few things to that problem that you're going to also need to know, and then I'm going to let you try one tonight. Okay. Tomorrow you'll do a formative assessment where you'll try another one, and then we will dig into this even more next week. Okay, so we have some time. I just want to introduce you to this today, get you started on one, but you might have some questions, and we'll have plenty of time next week before we take our test to make sure we get that ironed out. So here we go. I'm going to read the question, and then I'm going to go back and give you the formula. So number 21 says, at time t equals 0, a ball is thrown upward at a velocity of 10 feet per second from the top of a building 50 feet high. The ball's height is measured in feet above the ground. Is the initial velocity positive or negative? Why? And write the motion equation that describes the height at a time. So I did my best to draw a little building here. Here's your person. They're going to throw a ball with an initial speed of 10 feet per second. The ball is going to go up, obviously, but then and I want to be clear, it doesn't matter how much horizontal, like if we threw it out or if we threw it straight up, okay, that doesn't really matter. We just had an initial upward velocity of 10 feet per second, okay? So it might have had some horizontal velocity to it as well. We're not worrying about that right now. So 10 feet per second up. So we threw it maybe just far enough so that it cleared the building, and then it's going to come down like this. Okay? So that's our situation here. So we need to come up with an equation. Now, like I said, the book works through most of the lesson to get you to this understanding by the end. I'm going to start with this, and like I said, encourage you to look back through it a little bit, try and make some sense of it. But here we go. H equals -1/2 g times t squared plus v sub 0 t plus h sub 0. What do all these things mean? If you've been in physics, you probably have a pretty good idea. Here we go. G is called the gravity constant. Gravity obviously has a constant pull on us. When you're talking about feet and seconds, this is your constant number, 32. If you're doing meters and seconds, it's 9.8. Okay. We're going to stick with feet, try and keep it simple. V sub 0 is the initial velocity. H sub 0 is the initial height. Now, that problem aside for just a moment, if we plug in our 32 for G and take it times -1/2, we get -16 t squared. The initial velocity will depend on our problem, as will the initial height. This right here, students, is what you need to know and use. All right? From there, in our problem, what do we know? Okay. What is our, well, let's just say it. Our initial velocity was 10 feet per second. And it's positive. Velocity matters the direction. Since we're throwing it up, it's positive. Velocity has direction. If we were throwing it down, then it would be negative. But in this case, it's going to be positive 10 t, just like that. And then our initial height was 50, Again, feet. So they have to be in feet and seconds. If not, you're going to have to do some conversion. But there you have it. So technically, that's all that the question wanted, all right, was to be able to figure that out. Hopefully that's pretty basic now. What I want to do is ask some follow-up questions that you'll eventually be working with. And I need to pull it up on my screen a second. Okay, so here's the next question I want us to do. What is the maximum height of the ball? Okay. So, what is the maximum height? What is this point right here? How high? We know from here down is 50 feet. Okay, and we know it got thrown upwards 10 feet per second. How high did it get to? Okay, how high? All right. Well, notice our function here. This is a height function. You put any time in there and it will tell you how high you get. So just like the video you watched on Wednesday, we want to maximize this. We want to find what's the highest height. All right. And to do this, the best way is to look for that vertex. That's going to be the vertex of our parabola. And we know how to find the vertex. Negative b over 2a. That's the easiest way. So negative 10 over 2 times negative 16. And we come up with negative 10 over negative 32, which would reduce to, what could we take out of both those? A 2, 5/16. So at time equals 5/16 of a second, we hit our highest point. But that tells us when we get there. That doesn't tell us how high we actually got. So what do you think we should do with this number to figure out how high we got? If you answered plug it into your function, you're exactly right. So when you take h and plug in 5/16, okay, you can evaluate that function just using your calculator. For the sake of time, I'm going to go back to my notes here. And when you do that, you should come up with, and I would encourage you to check this for yourself, make sure you can get this value, 51.56 feet. Huh, that's interesting. We were at 50 feet, it only went 51.56. So 10 feet per second for an initial velocity is not very fast. So this person barely threw it up. It only went about 1.5 feet higher than the top of that building and then came down. So it was kind of a wimpy throw, but that's where we're at. Okay. All right. So one other question I want to ask and then answer, and hopefully, maybe you guys could have even come up with this question by just thinking about, what are you curious about in this? Well, we're curious about how high it gets and how long it took to get there. We're curious when it hits the ground. Okay? A calculus question is also curious about how fast is it going when it hits the ground, assuming no air resistance. Okay? But let's see if we can just figure out when it hits the ground. Okay, how much time has passed? All right? So, what do we know about that point down here? Well, we know the height at that point is 0. So we go back to our function, and we know the height, not the time, we know the height is 0. So we can put 0 in for h of t. And then we have negative 16t squared plus 10t plus 50. So look right here. This goes back to what we did earlier this week, where we had a quadratic equation set equal to 0. How do we solve for t? Well, we do that using the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. I would encourage you right now to pause the video and plug those values in, b, a, and c, and see if you can calculate your time values. You'll get 2 answers. Only one of them is going to make sense. The other one is actually, if you went backwards, you're going to have this negative time over here. We want the positive one. So pause it. See if you can get the answer. I'm going to quick look at what I did here. So on my notes, when I plug this in, I got negative 1.48, but we said that was not going to be one of the solutions. The one that we want is 2.107 seconds. So it didn't take very long, 2.10 seconds to get down and hit the ground. Okay, like I said, this is just an introduction. Hopefully it got you going. You're going to try one tonight. Email that to me. You'll do one tomorrow on your formative assessment, and then we'll get after it even more next week.